Hello everyone. In this session, we'll deal with the introduction part of HVAC. First we'll discuss what is HVAC. Then we'll talk about the Standard Society ASHRAE. And then we'll deal with what exactly the heating is, ventilating, and the air conditioning. Then we'll also discuss about the Standard Society, etc. Okay. So today is going to be an introduction session for the HVAC field, which is very basic, and at the same time, without this basic, you cannot think to deal or you cannot think to move to the next step. Okay. So if you are a beginner, this class is for you. If you're experienced, then you'll get some new point. But as experienced people already aware what is HVAC, what is ventilating, etc. Today, as I said, is the introduction session for the HVAC. In the previous session, we learned about the syllabus, what you're going to learn in this training program. I think you got the clear idea. What are the things I'm going to explain or we are going to deal in this training program. So I'm going to start the training from today only. Okay. So let me proceed. So on screen, you can able to find the notes. And here we'll start with the very basic with the chapter 1. So chapter 1 is for mindset. In the chapter 1, you're going to get the idea. What is HVAC? Okay. And the requirement for this service and how this is important for human comfort, how this is important for process control, etc. Because you see, if you talk about HVAC, you'll find this HVAC not only in residential, not only for human comfort. This HVAC is required for residential project, commercial project, and even for industrial. Actually, the idea of this air conditioning by Dr. Willis Evelyn Carrier, he is the father of air conditioning. Actually, the idea of this air conditioning by Willis Carrier is to provide the favorable condition for a printing press. Okay, with that the idea start, and later this is used for the home and comfort. So originally the idea for air conditioning is for process control, but now in market we are using in almost in all the applications. So you can find this air conditioning or this HVAC in residential, in commercial, in industrial, and no doubt in automobile, in all these vehicles you'll find this air conditioning. So you can think the scope or the future of this field. Anyhow, those who are working on in this field, they know, because you see this is a part of building service, and you know the future of this building services. We'll discuss some new trends also, like green building and BIM at the end. Okay, so let me start with the very basic. First, what is HVAC? And this can be the expected question at the time of interview for beginners as well as for experience. Generally, the interview start with the term. They will ask what is HVAC. Okay, so you should have the clear idea about this. What is HVAC? In short, we used to call HVAC. It's a heating, ventilating, and what air conditioning. In short, it's HVAC. So it's a technology, or I can say it's a process and use with the system. So you see, HVAC is a technology and a system used to provide what? Thermal comfort and the indoor air quality. Okay, so this indoor air quality we'll discuss in detail, talking about the ventilation. In various environment, it involves regulating temperature. These are the parameters. So temperature is a major parameter for maintaining this air conditioning, and the humidity, no doubt, is important for human comfort as well as for the process control. This humidity also a major parameter. Then air circulation, I'm talking about the distribution of air, and proper distribution and proper circulation of air also one of the major parameter for this air conditioning to get the required or to get the desired results, and to create a comfortable and healthier living or working space. So HVAC systems are commonly used in homes, nothing but residential, commercial buildings like school, office, malls, etc., and no doubt industrial facilities, and you see vehicles, to maintain optimum conditions for occupants and process. So I think you got the idea what is HVAC, at least the basic. Next. So step by step we'll proceed. So you see, whenever you talk about this HVAC, air conditioning or heating, ventilating, etc., this standard society will come into picture. And again, this can be an interview question, because they may ask, did you follow the ASHRAE standard, or which standard did you follow in your previous project or at the time of learning this training, etc. Okay, so most commonly in actual practice or globally, except a few locations, you will find this ASHRAE. So what is ASHRAE? In short, we used to call ASHRAE. It's American Society for Heating, Refrigeration, and Air Conditioning this engineers. It's not a company, it's a society, and deal with what? Research and development for this HVAC, including R. R means refrigeration. And you see, the aim is to provide or to serve a resources for research, standards, development, education, and collaboration with the HVAC and R industry or a community. So this is not a company; it's a society. Okay, and they're serving a lot of, or they're contributing a lot of things to this HVACR industry. So that's the reason in actual practice, if you're working in US, or if you're working in India, or if you're working in Gulf, mostly will refer to ashtray. Okay, even if you refer ashtray, most of the things you can relate with the ashtray. But ashtray, if you're using with the ashtray, if you're in India, again most of the thing is a reference from ashtray. Okay, because ashtray is an international society. But if you are working in UK or New Zealand, the societies are different. So anyhow, focus on the concept, because the society may vary or the standard may vary. So if you learn the focus, then you can able to deal with the different standard society. But most commonly in actual practice, or most of the location except few locations, you will find the ASHRAE standard for this HVAC and R industry. Okay. And this is important for interview point of view. You should know the abbreviation for this. It's the American Society of Heating, Refrigeration and Air Conditioning. Topic is about home and comfort standard, because if you're talking about this HVAC, means air conditioning, in most of the cases, we bother about, or we are maintaining this conditions for home and comfort. No doubt we are using for industrial process control also. But first we'll talk about this home and comfort standard. And when you talk about home and comfort standard, we are following this ASHRAE standard 55. Remember this standard, ASHRAE 55 is for home and comfort standard. May ask in interview. And according to this ASHRAE standard 55, we have some guideline, especially for home and comfort standard, at what temperature the human will feel comfort at different applications or different conditions. What are those conditions? You'll find in the next page only. You see, home and comfort standard and guidelines are the parameter used to define the condition in which the people feel comfortable, in indoor environment. You see, when you talk about the HVAC, means we are talking about the indoor side. And now in market, in the latest technology, you'll find the outdoor air conditioning also. And their outdoor air conditioning is even new for me. I've not done any project in that. But I heard in Qatar project, they did the outdoor air conditioning also. But I'm not much aware of that. But generally, means default, when you talk about air conditioning, means we are talking about inside the building, means indoor. So still the definition, in the definition, you'll find the indoor environment. In future, it may be indoor plus outdoor environment, because the outdoor air conditioning also started. That is a different story. So back to the topic. You see, these standards take into consideration factors like temperature, as we discussed at the beginning also, humidity, air movement, and clothing. This is a new factor. Clothing also important parameter for home and comfort. So based on the type of clothing, the feeling will change related to the thermal point of view. Okay, so this based on the clothing also, the comfort temperature may vary, and that you'll find in the next table only, as well as the personal preferences. And you see, feeling comfort is depend on one health, one food type. For example, a person is eating more or higher calorie food, his body will release more amount of heat. The rate of heat release is different compared with the, means person to person, depend on the type of food, also. So the clothing and the food and other parameter depend on the health condition also, even the age. So it is not possible to go for a standard fixed temperature for all human for all human being. So we have a range, we have some standards. Okay, so nobody can give the exact temperature. This is the only temperature so that everyone feel comfort now. So it depend on n number of parameter. But based on the research and based on that development and from the societies, we have some standards that will follow at the time of designing for different applications. And you see, which provides recommended temperature and humidity range for different types of activity and the clothing level to ensure the comfort requirement. Okay. So for the building occupants. So, but what are the conditions, or what are the parameters based on the research? You can find in this table. So let me jump to the table first, then we'll talk about this graph. So you see in this table, again, this table is a reference from ASHRAE standard, ASHRAE 55 standard. You see, general home and comfort standard based on ASHRAE 55 for indoor environment. So here is the example. You see, sedentary work, the standard temperature I've given in centigrade as well as in Fahrenheit. For example, we'll discuss with the centigrade. So 20 to 24. If someone is working in a sedentary way, So the temperature, standard temperature in between 20 to 24 degrees centigrade. Okay, so nothing but 68 to 75 degree Fahrenheit. Light work, you see 20 to 23, 1 degree less compared to the sedentary. Similarly, moderate work, we required less temperature, because moderate work means compared to light work, the heat release is more, na? So we required less temperature to maintain that comfort. Okay, similarly, you see heavy means still decreasing. From here 22, now 20. So as the activity increases, it means the heat release or the rate of heat release from the body also increases. Okay, so that's the reason lower temperature is required for that comfort. I think you can able to relate. This is the one parameter. Here I'm just considering with the activity. This depend on the clothing and other parameter also, but it is difficult to consider everything. So we have some standard based on the important parameters. Similarly, you see summer clothing 23 to 26, in between winter clothing 20 to 23 degrees centigrade, in case of Fahrenheit 68 to 73. And on the right side, if you talk about the humidity level, you see in most of the condition 30 to 60, the range is fixed. Only in summer clothing 40 to 60, but remaining is what, 30 to 60s. And this can be interview question. The standard or the standard range for RH, nothing but relative humidity. At this level, if you are a beginner and if you don't know what is RH, don't worry, we have a separate topic in chapter 4 at the time of psychometry. But I believe as a mechanical, you should know what is RH, relative humidity. Okay. But don't worry, if you don't know, we'll discuss. Maybe you learn in engineering 5 years back or 10 years back, so you may not or you may forgot that one. So don't worry, we'll discuss. We'll refresh all the basics also. After completing the basics only, we'll start the building survey chapter 6. Okay. So relative humidity range 30 to 60 in almost all the condition, and in this I'm talking about human comfort. Again, this relative humidity is not for the process control. For example, if you're dealing with the say server room, for server room 10 to 20% range is enough, because we don't require the humidity for the machine. Means I'm talking about the server, because if you increase the humidity for the server, the life of the server will decrease, because we don't require that much moisture in the server room, or in many process control like printing press or different equipments, we don't require the moisture. So this range is for human comfort. What we are discussing is not for process control. For process control, based on the application, based on the equipment, this may vary, and the best can provide by the vendor of that particular equipment. Okay. So now you see, in general, for interview point of view, this comfort zone chart, which is taken from ASHRAE Handbook Fundamental 2001, you see, just for learning point of view, the range in general for learning point of view, or for even for interview point of view. You see, this is a part of the psychometric chart. This is a part taken from the psychometric chart. And in the psychometric chart, you'll find RH line, temperature line, and the dew point temperature, etc. Again, still, if the psychometric is new for you, don't worry. We have a topic in chapter 4. Now, just try to understand the concept. You see, here you can find the winter range and the summer range. And if I just pick the points, this is just for understanding, and this numbers again may vary slightly as per the standard. You see, here the winter range start nearly at 70, so I'm considering say 68. You can find out the winter range 68 to, you see, this is a point, because this is a common summer and winter, but the winter up to this point. So you see, this is up to 76. So the winter range is 68 to 76 degree Fahrenheit. So you see this line, this line is for this 60, and all this you can find out it's a temperature direction. And this line is for RH. I'll give you this, but first of all, focus on the temperature. So you see the winter range start from this 68 up to this 76. And if you talk about summer range, you see 74 to this, you can find out nearly 82. And again, it's not exact, it will plus or minus up to 3 degree as per ASHRAE. We have a tolerance. So 74 to 82 is a comfort range in summer, and 68 to 76 is a comfort range for winter. And in both the cases, you see 30%, 50%, and 60%. These are RH line. And you can check RH line, 30% is crossing winter and summer, 50% also crossing this winter and summer, even 60% also. This line is touching to this winter and summer range. So it means the range is 30 to 60 both the season. Or as standard for learning point of view or for calculation point of view, we're considering 50 as standard, 50% RH. At the time of load calculation for human comfort, you're considering 50 as standard, but the third in between 30 to 60 also accepted. There is no issue. So this is about comfort zone chart from ASHRAE. This from ASHRAE 2001 fundamental. Okay, and again this is you will find in the ASHRAE 55 standard also. Okay, so this chart again, this table. So hope you're getting my point. So now the conclusion is for different applications, 1 minute, for different applications, you will find the different temperatures and the different RH range. And what we discuss is for human comfort. If we talk about process control again, this range will vary. So next, heating. So let me define the heating. Again, this is very basic and may ask an interview. They may start with the HVAC and they ask you to define this HVAC. So what is heating? So very basic. So please bear with me. Experienced people, please bear with me. Anyhow, you'll get some new points for learning. But for beginner, this is must. You must focus on each and every point. And this course, what we design is right from the basic to the advanced level for the beginners as well as for experience. So sometime the experienced people should bear, or sometime the this beginners must bear. So because it is not possible to go for a separate modules for different participant, because it is difficult to manage. So now you see, back to the topic. Heating is what? Heating in air conditioning refers to the process of increasing or raising the temperature of indoor to provide what? The comfortable condition with respect to temperature, or to maintain the warm and comfort in colder conditions. So in short, I can say heating is providing the heat in order to maintain the standard temperature. And what standard temperature just now we discussed now? For example, say 72 standard we are considering commonly in actual practice for designing 72 degree Fahrenheit. Start with 62. Now in between we can consider 72 as standard, or for summer we can consider say 75 or 76 as standard. I'm talking about Fahrenheit. I don't think that for centigrade means people will burn. So heating in air conditioning is refers to the process of increasing or raising the temperature in indoor to provide the warmth and the comfort in colder conditions, while air conditioning often focus for cooling and heating, but as per the requirement we can provide. So in short, heating is providing the or increasing the heat to increase the temperature to maintain the standard temperature in winter. Okay, if the temperature less than the standard, and the standard temperature what we discussed in the previous in the previous page. Okay, so that is a set point you can consider. If the temperature is less than that, heating is required. If the temperature is more than that standard, then cooling is required. Okay, so with that set point we can decide when cooling is required, when heating is required. So in general, you can understand heating is required in winter and cooling is required in summer in most of the locations. But depend on location. In some location, the summer temperature is so low compared with the other locations. So that depends. So that's the reason again, the standard temperature will help to decide when heating is required and when cooling is required. And how to provide this heating? There are a number of ways to provide the heating. Some of the systems I listed here. So you can use the furnaces to provide the heat, to produce the heat by using the natural gas or the fossil fuels, coal, etc. This is an old method, very old method. Furnaces, with the furnace will produce the heat, and that heat we can use with the system. That system we'll discuss later. Similarly, heat pumps. The heat pump can extract or it is used to exchange the heat. In short, at this level, I'm not going in detail because this is just a starting session. Similarly, electrical resistance heaters producing the heat with a high grade energy, that is electricity. So with the electrical energy, if you produce the heat, means we're producing the low grade energy with the high grade energy. Okay, so but where you cannot find out this fossil fuel, natural gas, etc. Scarcity of that, we have this electrical resistance heater, or it's a compact system compared with the furnace. Next, we have a radiant heating. Radiant heating means we'll lay the pipes in the floor and we'll run the hot water. In short, at this level, okay, we'll discuss about the systems later. Or using the boilers. As a mechanical, I think everyone know what is a boiler. So with the boiler, the hot water from the boiler we can use to circulate in the coils and in the AHU or in the FCU, or you can call water supply heat pumps, and to provide the hot air. Okay, so boiler also can be a source for providing the heat. So this is about the heating. So heating is providing the heat or increasing the temperature to maintain the comfortable condition in case of the temperature less than the standard or in winter condition. And these are the different sources to provide the heat in general. Okay. Next in HVAC, V stands for ventilation or ventilating. And this is also very, very important, especially for human comfort. Without ventilation, if you just maintain the temperature, is providing the hot air or provide the cool air as per the season, that will not be enough, because if you not maintain the quality of air, as a human we cannot feel comfortable, because as a human, as per the metabolic activity, we are breathing na, and we are extracting, or we are inhaling what, oxygen, and releasing what, CO2. So the quality of air is very, very important, and the quality of air, this ventilation is related to the quality of air. So you see, ventilation in HVAC is refers to the process of exchanging the indoor air with the fresh air from outside. So what do you think? The indoor air or the outdoor air, which is polluted? The indoor air is more polluted or the outdoor is more polluted?
Indoor is more polluted.
Outdoor is more protected.
You see, with respect to oxygen, you see here I'm talking about with respect to oxygen. So if you talk about with respect to oxygen, indoor air is more polluted. The reason,
Yes.
because you see, we are consuming this oxygen continuously and releasing the CO2 now. So if the room is totally packed, what will happen? And some people inside that room, so what will happen after some time? They will consume the entire available oxygen, and the CO2 level increases. And if the CO2 level increases, means you cannot breathe easy. And if you cannot breathe easy, and if you are maintaining the temperature, means there is no question of feeling comfort, right? So that's the reason this is very, very important. So remember, indoor air is 90% polluted compared with the outdoor air with respect to the oxygen level. Or in other words, I can say the outdoor air is 90% fresh with respect to oxygen level compared with the indoor air. And that's the reason we are using the term called IAQ, in indoor air quality. Okay, if you talk about this IAQ, this term is used in ASHRAE, IAQ, indoor air quality with respect to ventilation. Okay, so ventilation is not just means not just for exchanging the indoor air, and this is for the comfort with respect to the oxygen level for human. So it's a process of exchanging indoor air with the fresh outdoor air to maintain indoor air quality and provide a comfortable and healthier environment for occupants. And you see, no doubt, outdoor air, maybe with the pollution, maybe with the contaminants, maybe with some other particles, etc. So when before providing, we are filtering with the filters. Okay, but again, I'm talking about with respect to oxygen level, outdoor air is 90% fresh compared with the indoor air. Next, you see the pollutant outdoors, excess humidity. This also one parameter, and the CO2. This is again CO2 means with respect to the oxygen level, na? And for maintaining the oxygen level in the closed spaces. And you see, if you're working in an office, in a large area office, and if you not get the proper oxygen, so what will happen? That will directly affect to the efficiency of your working. And that's the reason in Western countries or in many countries, if you not provide the proper fresh air or proper oxygen level in the indoor environment, especially in offices or in school or in public place, etc., the authority will not allow to start the functioning of that. Okay, so this is so important. So this will directly affect to the efficiency of the employees in office or in the school for the students. So in short, providing this ventilation is what, providing fresh air from outside to maintain the quality of air with respect to this. The odors means the bad smell, and to maintain this again for humidity point of view. But the major point is the oxygen level, to maintain oxygen level or to exhaust that the CO2. Okay, and we have a different ways to provide the fresh air. What are the different ways that we'll discuss in load calculation at the time when we talk about the heat gain through ventilation. Next, you see further some more points. The indoor air quality, what I explained. Then resolution of outdoors, this odors, the bad smells. This is also important. Then humidity control, temperature regulation. Temperature regulation not in all the season. For example, if the outside temperature is less and indoor is more because of the internal components, in that case, that exchange of heat will also help to maintain the temperature. So for that, we are using economizer. We'll discuss what economizer is just at this level. Think that in daytime the heat is releasing from is transferring from outside to inside. So in the evening time, the heat is completely inside the building, and in the evening time, the outside temperature is less. So when we circulate the outside air to inside, and when we do the circulation, that will also help to reduce the temperature. So we can take the advantage of this by circulation with the fresh air, but not all the time. Okay, and no doubt, very very important, oxygen supply. So ventilation can provide with the
So,
natural
sir,
type.
can you
Yes,
repeat this? Can you repeat this concept once again?
which one?
An economizer concept. That means you are saying that in the evening.
Economizer means if the outside temperature is less than inside, in that case we are increasing the exchange of this fresh air, and that is done with the dampers, automatic motorized dampers. And with the head, with that we can save the energy, as well as we can maintain the quality with less energy. I think you got the idea online about the economizer, but don't worry, economizer is not explained yet, just have given the reference at this level. Just remember, if the outside temperature is less compared to inside, and in 24 hours, for example, generally in the evening time, in that case we can provide more outside air, so that we'll get the advantage of saving the energy by maintaining this temperature. So ventilation can provide, that can be a natural ventilation, just simply open the windows or doors, what we are doing in our houses, or it can be a mechanical ventilation using the exhaust fan, or in technical term we are using FAHU. That is a fresh air handling unit, or we can also use a TFU. We can also call as a TFU, treated fresh air unit. All these terms will use in detail. We'll discuss in detail. Don't worry. Just I'm giving the idea at this level, because this is just a introduction session. So I think got the idea what is ventilation and the importance of ventilation for human comfort. And next time you see, especially when if you're in your room, if you're using a split AC or window AC, remember there is no fresh air option in that. And if you close all the doors and windows, and throughout the night if you sleep just switching on that split AC, if there is no exchange, or there is no exchange of the outside air, and if there is no maintenance, if there is no proper oxygen level, when you wake up, you will feel very low. You'll not get the energy, because the reason, you're not getting the proper oxygen for breathing, and as a human we require this oxygen. So this is very very important, so be careful even for your day-to-day life also. So I think got the idea online about the ventilation. Any questions here related to ventilation? Just concept at this level. You see, I'm not explaining everything of ventilation in one class, just I'm explaining the concept, because this is just a class one.
Sir, is there any standard for the ventilation ASHRAE standard?
Yes, ASHRAE standard 62, ASHRAE standard 62, ASHRAE standard 62.1. We have career standard, we have safety standard, we have consultant, the consultant own standard or authority standard. The list of standard that you will find in chapter 7 at the time of load calculation, especially ASHRAE standard 62.1. And you'll find a separate PDF of 90, I think 93 pages of ASHRAE standard 62.1. Okay. Next. Like we have ASHRAE 55 standard now for human comfort. Similarly, we have this ventilation standard, separate standard. Next we'll talk about air conditioning. So HV and AC. So again, this can be an interview question. They may ask you to define what is air conditioning. So you see, it's a process of treating air in an internal environment. Still, it is internal environment. As I said, in future, it can be, the definition may change, internal as well as external. But as of now, internal. So it's a process of treating air in an internal environment in order to establish and maintain what required standards of temperature. So we can increase the temperature or we can decrease the temperature as per the requirement, means heating or cooling. Relative humidity, this is important, RH. And if you don't know what is RH, we'll discuss in detail in chapter 4, psychometry. You see, I'll just give you the idea. If the RH increase above the limit, for example, if the RH level is 70% in the room, you will feel a lot of sweat, and you cannot breathe easy. Similarly, if the RH level less than 30%, what will happen? You'll feel dryness of skin, like generally in winter season. So because in winter season the humidity levels are less, and in summer season the RH level is high. Okay, so the more in detail we'll discuss in chapter 4. Don't worry. Psychometry. So at this level, RH level also important. Next, cleanliness of air. This is also one parameter to maintain. You're maintaining temperature, you're maintaining oxygen, everything, but you're getting this bad smell, or if you're getting this pollution or the virus inside, means there is no question of this maintaining the quality of air. So again, cleanliness is a parameter of this ventilation. You need to maintain the cleanness of air, and motion of distribution. This is also important parameter, and this we'll discuss in detail with the air distribution side. We have this separate part for this part 4 is for air system. No? So in that we'll discuss how to maintain this proper motion and distribution by using the circuit called duct with the 8 terminals, etc. In case of central air conditioning system of air and noise level, this is also important. This noise level also important parameter. Suppose if you are supplying the air with the higher velocity, and as the velocity increases, the noise increases. Both are directly proportional. This part also important. We'll discuss at the time of duct designing. So noise also one parameter to maintain, especially for human comfort. Again, this is not applicable, or this you can ignore for process control, because the machine will not get disturbed with the noise. Okay, depend on condition. If the again machine with the operator, then again for operator, for human we need to maintain the noise, or else we cannot focus on his work. But if this self-operated machine, in that case we can ignore this point, and even RH also we can maintain less than the standard, less than 30% as per the equipment requirement. And if you talk about human comfort, the noise level should be less than 35 decibel, because less than 35 decibel means it will not create irritation or disturbance to our ears. Even up to 40 dB, or even up to 50 dB also okay, accepted, because you see at present in my room, you see, or else in your room, if the fan is running, you can, the noise from the fan is nearly up to 40 or 45 dB. That is okay. But if you're talking about the standard point of view, then it should be less than 35 decibel. Okay, so and that can be maintained again by proper maintaining the velocity of air, because velocity is directly linked with the noise. As the velocity increases, velocity means I'm talking about the air velocity. As the air velocity increases, the noise also increases. So this is also one major parameter at the time of duct designing. Okay, so we'll discuss more about this. So this is about the air conditioning in general terms. But now if you talk about the air conditioning as per ASHRAE, you see, this may again ask in interview, that says added. So air conditioning is defined as a process of treating air so as to control simultaneously its temperature, humidity, cleanliness, and distribution to meet the requirement of the conditioned space. Or in other words, I can say, as per ASHRAE, it's a condition of air. It's a condition of air in which the human mind should feel comfort, and when the human mind feel comfort when the body, and when the body will feel comfort when you maintain all this parameter. So this is about HVAC. I think what the idea. Next, we'll talk about application. Application as given at the starting.
Sir, one question.
Yes.
So ventilation means addition of fresh air from the outside, as
Yes.
well as exhaust of air from the inside, also, right? So ventilation means addition of fresh air from outside, right? As
Yes.
well as, yes, as well as exhaust from the inside to outside, right?
You see, when you provide the fresh air from outside, so what will happen? The pressure in the room increases, no? So
Mhm.
definitely exhaust is required. But in most of the cases, we don't require a separate exhaust system. Exhaust can be done, that we can call common exhaust. Or whenever you open the door. Anyhow, don't worry about that. That we'll discuss in detail at the time of air system. But what you're thinking is correct. When you provide the fresh air, means definitely there should be some provision for exhaust also, or else the room will means continuously providing the air from outside, and there is no means exhaust, means what will happen after some time, the movement of air decreases, and the pressure inside the room increases. That will affect to the back pressure of to the equipments. So definitely what you're thinking is required, and for that we have provision also. We have a separate supply duct, separate return duct, separate exhaust duct, separate fresh air duct, and a lot of things to discuss. Okay.
So both the things are called ventilation, right? Addition or
Exhaust
exhaust.
is a part of ventilation, we can say. You see, again in ventilation, you find the exhaust system like car parking exhaust system, kitchen exhaust system, toilet exhaust system. That also comes under ventilation. But in that, we'll focus more on the exhaust. When you exhaust, the fresh air will introduce. But don't worry. It's too early to discuss that points, because the other people may get confused. At this level, just what I'm explaining is what is HVAC. Yeah, so now if you talk about this application, as I said at the beginning of the session, air conditioning or HVAC is used in what residential, commercial, or industrial. The list will continue. You see, residential buildings. Later, I'll share you this notes. You can read all the points. Just I'm giving the highlights. So in residential buildings, in commercial building, in industrial for process control, in hospital, healthcare, in hotels, hotels, or in data center. This is a common example. Transportation. The list will continue. So in short, I can say in almost all the application, including this automobiles, you'll find air conditioning. Some some application I've listed in the notes, but the list will continue. So for example, you see entertainment venues like malls, theaters, etc. Education facilities, you can relate. Clean rooms, if you don't know clean room is where example of one clean room is preparation of medicines or preparation of or manufacturing of Intel motherboards or precision equipments. That area we used to call clean room. Nothing but in clean room, the concept of clean room is we are trying to provide 100% fresh and clean air. It can be with a different range, but in general, 100% fresh and clean air with the laminar flow. So it's a special case. Similarly, greenhouse for this planting site. In that also we need to maintain the conditions. Okay, so in almost all the application we require this HVAC application. So now you can think the scope of this field. So this is about the HVAC in application. Next, some standard societies. This is also important for interview point of view, because here we are living in the modern world. Okay, if you design something means you should have some reference. Now if you submit your design to the main consultant or to the concerned person at this level, because if you don't, the beginners may don't know what is consultant, contractor, etc. That I explained in chapter. So at this level, for example, if you design something and if you submit to the concerned person, so what do you think, your design will blindly accept? No, you must have some reference. You must have some standards, because we are living in the modern world. So based on the previous research, previous years research and development, we have a lot of data to use. So that standard, one example is ASHRAE. Already we discussed the same. You can find in the list. So we'll talk about the standard society. With the standard society, we can use the standards. We can use the codes, and that we'll use at the time of design, so that your design is going to accept as per the application, as per the consultant or the client requirement. So in the list, first you'll find ASHRAE. So everyone know what is ASHRAE, American Society of Heating, Refrigeration and Air Conditioning Engineers. It's a society based in US, and they are dealing with the research and development for this HVAC in our industry. Okay, you'll find the n number of standards. So you can go to this ASHRAE website and you can find out the n number different standards. So at this level, you see ASHRAE standard 55, we discuss home and comfort, and ASHRAE 62.1 ventilation standard. Similar in ASHRAE handbooks, you'll find ASHRAE fundamental handbook, ASHRAE refrigeration handbook, ASHRAE application handbook with a different edition. And now in market for fundamental, I think 2021 is the latest one. ASHRAE Fundamental Handbook 2021 is the latest edition. Similarly, for application, 2022 is the latest available, and in refrigeration, I think 2006. I'm not sure about the refrigeration. You'll find the different handbooks also in ASHRAE. So for design point of view, remember we are following ASHRAE Fundamental Handbook, and that 2021 latest edition is available. So in the class also, I'll use ASHRAE 2021. Previous we use 17 and 2009. But as I said, I'm updating, so we'll follow the latest available standard, which is 2021 for fundamental. In the ASHRAE Fundamental Handbook only, you'll find this design for this residential as well as for commercial. You'll find separate application. So I'll give you the idea about this handbooks. Don't worry. Next society we have a SMACNA. So SMACNA is what? Sheet Metal and Air Conditioning Contractors National Association. So this society also based in US. They are dealing with the research and development for the ducting side. In short, duct is a passage used to convey the air. Let me quickly show one image for beginners. We have a separate part 4 in module 1 for ducting. At this level, just I'm giving the idea. You see this sheet metal box, or else I'll show you the simple image. You see this sheet metal box is a passage used to convey the air. We used to call duct. Okay, in detail we'll discuss in part 4 of module 1. So you see, when you talk about this duct design, duct installation, duct drafting, etc., we'll use this MACNA as a standard, commonly in actual practice in India, in Gulf, in many locations. But if you are in UK, then you're supposed to follow DW144. This is a European standard, mostly in UK for this ducting site. Next, we have AHRI. Previously, it was ARI. You see, in previous year, we used to call ARI, but now it's a AHRI. It's a Air Conditioning, Heating and Refrigeration Institute. And this society is dealing with the equipment side. You see, manufacture of HVACR equipments. So when you talk about the standards for the equipments, we'll follow this AHRI. So generally on the equipments, you'll find the AHRI logo. It means the standard equipment. So next, ESHRE. If you're in India, you're supposed to follow ESHRE. Similar like ASHRE, we have ESHRE, Indian Society of Heating, Refrigeration, and Air Conditioning Engineers. And if you're a student, you can take the membership, student membership from ESHRE. Or if you are a professional, they are offering the professional membership also from ESHRE. So you can contact to your local ESHRE. ESHRE is available in Hyderabad, in Pune, in Bangalore. They have different chapters. So you can contact and take the membership. It's not expensive. Get the updates. And if you can afford, you can take the membership of ASHRE also. Next. So next is IS, Indian standards. So in many locations, in India, if you're dealing with a project for especially for ministry project, you need to follow this IS. Next is ASTM. So you see, when you talk about the materials, ASTM will come into picture. For example, to fabricate and install the duct, we are using GI. Similarly, for copper piping is used for refrigerant side. And chill water pipe, for chill water pipe, we are using black steel. Not only in HVAC, if you talk about plumbing, firefighting, electrical, or even piping or other fields, when you talk about the material, we'll use the same standard, ASTM standard. ASTM is what? American Society for Testing and Materials. In short, ASTM. So this is related to the materials. So how we come to know that copper is a good option for refrigerant piping. GI is a good option for ducting. So based on this research and development from ASTM. Okay. Next, SIPC. If you are working in UK, then you are supposed to follow SIPC. SIPC is a what? Chartered Institute of Building Services Engineers. In short, we used to call SIPC. Like ASHRAE for US or in Gulf, we are mostly following ASHRAE standard. But in UK, they have their own society. They have their own monopoly. So they don't want to follow US. So they have their own SIPC guides. Okay. Next, DEWA. If you are in Dubai, so we have a DEWA, Dubai Electricity and Water Authority. In short, we used to call DEWA, or else you'll find DM, Dubai Municipal, for the ventilation standards. Okay, anyhow, in Dubai, you'll find ASHRAE standard 62.1. So most of the Gulf region, you'll find the ASHRAE standard or SMACNA, ASTM, etc. Now, if you're working in Qatar, you need to follow this Qatar Municipal, that is the Kharama, Qatar General Electricity and Water Corporation. In the name of that municipal is the Qatar Kharama. So you need to follow the standards from Qatar Kharama if you are working in Qatar for especially major project to get the approval for your project. Similarly, if you are in Saudi, we have RC, Royal Commission for Jubail, Royal Commission for Yabo, Royal Commission for Riyadh, etc. They have their own standards. So especially again for approval point of view for ministry project or for approval point of view for the private projects, you need to follow this RC standards, Royal Commission. Next, LEED. You see this LEED, IGBC, USGBC, all is related to green building. So what is green building online? Any idea? Yeah, so you see the idea of the green building. So what you said is correct. With respect to what? With respect to HVAC engineer or for building services. But apart from this saving of energy, we have some more points to consider for green building. So first of all, before dealing with these societies, let me explain what is green building that you'll find in the next page. So green building, it not mean that the color of the building is green. So the green building, so green refers to what? Generally, green means we are using this term for saving of energy, for saving environment. So the concept, you see, concept point of view, the idea of green building is to save the environment. Okay. Saving the environment. And how to save the environment? By reducing the generation of CO2. And how to reduce the generation of CO2? By reducing the what? Power consumption. Because in most of the countries, still in most of the countries, the electricity generate with what? With the fossil fuels, with the coal, with the oils, etc. And with the fossil fuel, for example, coal is used to generate the electricity, means when you burn the coal, the CO2 will release. Okay, so the idea of green building is to save the environment. But if you talk about the definition, you see, a green building is one which uses less water. So if you're in plumbing, dealing with the plumbing service, you must think to save this water. Next, optimize energy efficiency. This is for HVAC engineer, because you see, if you talk about the energy consumption in building, means I'm talking about electrical energy. If you compare this consumption of electrical energy with the lighting, with the appliances, I'm comparing this lighting appliances with the HVAC equipment. You see, For example, 100% electrical energy consumption in building, out of which 60 to 70% energy consumption directly with the HVAC equipments. And in remaining 30%, you'll find other services and lighting, etc. Okay, so as a HVAC engineer, your role is to design your system with the maximum efficiency, means optimize energy efficiency, so that if you design the HV system in an efficient way for one project, similarly, all the engineers of your city design the HV system in an efficient way. And further, if you talk about all the engineers of the country designing the system in an efficient way, and further, if throughout the world, if everyone is designing the HV system in an efficient way, means everyone is contributing in saving the energy, na? And saving the energy means saving the electrical energy. Saving energy means electrical energy means the less generation of energy is required. Less generation means less release of CO2. Okay, getting a point. So as a mechanical engineer dealing with the HVAC, your role is to design your system with the maximum efficiency so that one can save the energy and you can contribute in saving the environment. Next, you see, conserve natural resources like solar, like geothermal or wind turbines. Now we have this wave turbines, a lot of new invention in the market with the natural resources. And in green building projects also, you'll find this. You'll find the solar system, you'll find the turbines, wind turbines, you'll find this other natural resources, so which will help to reduce the consumption of electric energy. And next, you see, generate less waste and provide healthier space for occupants as compared to the conventional building. Okay, so this is about the green building. The green building is not just a no, is not just a term; it's a process which is used which is used not only in HVAC, in almost all the services, including this architectural and structural side. Okay, even if you talk about this architectural side, the paint which is used inside the building, that also they are taking care of that also, because the paint, when heat up, it will reduce, or sorry, it will produce the chemical which is harmful for human breathing, that produce VOC, that chemicals. So in that also important. So the green building focus on saving of environment, saving of human health, lot of things. Okay, so now back to the topic. So if you talk about the green building, we have the standard society. On the top we have a lead. So what is lead? You can read on the screen: leadership in energy and environmental design. In short, we used to call lead, and this is related with the USGBC, United State Green Building Council. With that, they are offering this lead. And if you have experience, at least 1 or 2 years experience in this field, in these services, you can think to involve in this lead certification program. Okay, but not for the beginner. If you're a beginner, just get some experience in the field, then you can think for this lead certification. And if you're experienced, definitely this lead certification, writing the lead exam, getting the lead certification will definitely help in increasing the means. Definitely that will help you for your applications. If you are switching for the new job, that will help you for getting the job easily, and even for salary point of view, because you see many consultant or many companies, they are demanding lead certified engineers. So if you're experienced, you can think for this. Next, we have IGBC. If you're in India, we have this Indian Green Building Council. So you can write the IGBC exam also if you're in India. That will also help. Again, after IGBC, you can think for lead certification. Next, you cannot ignore this career. Career is not a society, it's a company. But still, in many consultants for the designing, they're following career standard. And we have a career handbook. And still in manual load calculation, in many countries or in many this consultant, still they are using career standard for manual load calculation. So we cannot ignore this. It's not a society, it's a company, but you cannot ignore. Why? Because it's the first company in the field of this air conditioning. And you see, CRRIR this is a name of a scientist, and you see the full name is Willis Hewlett Carrier, and we are considering him as a father of air conditioning. Okay, so he start in 1905 this company, and 1950 they developed, but the concept start in 1905 by this scientist called Willis Hewlett Carrier, and we are considering this is a father of air conditioning, and you can find his image also. So that's the reason we cannot ignore this carrier company. And from carrier, HAP. HAP is commonly used in actual practice for the load calculation. Carrier HAP. So you'll find the carrier standard. And now you see in many areas, the carrier is following ASTRAE standard. Okay, so in carrier handbook also, they are referring to ASTRAE standard. So ASTRAE society, and they are they are completely in that development side, but we cannot ignore the carrier also. If you talk about the load calculation manual, still we are using carrier standard. If you talk about the pipe designing, there's still water pipe designing. Even in ASHRAE handbook, you'll find the reference from carrier. Okay, so in this training program also, we are following this ASHRAE, SMACNA, and carrier standards. Okay, for metal point of view, we are following ASTM. So this is about the introduction part and end of chapter 1. Now, if you have any questions related to this topic, what I cover just now, we can discuss. So in the next session, we'll deal with the chapter 2. In chapter 2, you're going to get the idea, the process of designing and the process of installation, especially for beginners, how the process goes, the order of designing and the order of installation, so that you can you'll get the mindset. So with that mindset, we can start the training from chapter 3, means the technical part. Anyhow, this all introduction will also help. So chapter 2 is very, very important. So I'll give you the idea, the steps involved in designing with respect to the other services, and the steps involved in execution, the order, etc. The roles of a design engineer, the roles of execution engineer, etc. All you are going to get in chapter 2. Chapter 3, physics using HVAC, which is very, very important for the load calculation point of view. Very basic, very important, like sensible heat, latent heat, BTU, temperature scales, vapor compression cycle. All this we'll discuss in chapter 3. And after that, chapter 4, psychometry. Then we'll start building survey for the load calculation. After load calculation manual, we have load calculation in software. And that conclude till part 3 of module 1. In part 4, air side, part 5, water side for this HVAC designing. And module 2 is drafting. Those who join today only, for them, I'm just repeating this. Module 2 is drafting with AutoCAD. Module 3 is estimation, and module 4 is installation. Okay, then online, done for tonight. Thank you.